Okay. Now, once again, good morning. Yeah. So, after the rest from the previous classes that we had, let's continue with our learning lesson once again. So, already under state of matter, we've learned of the three states of matter. We've learned of the changes of state of matter and the properties, even the characteristics, and even what leads to the change in state of matter. And now in this next class, remember I told you that we're going to learn the pure substance. Why pure substance? Because sometimes, remember, you can be heating ice, okay, and it melts at a temperature that is less than 0 degrees Celsius. Remember, for ice, we expect it to melt at a temperature that is 0 degrees Celsius, and to boil at 100 degrees Celsius. The water is to boil at 100 degrees Celsius. But perhaps it fails to do so, in that it melts at a temperature that is less than 0 degrees Celsius. So for example, let's say at negative 5 degrees Celsius. And it also boils at a temperature that is above 100 degrees Celsius. So probably at around 110 degrees Celsius. So if such a thing happens, if you are heating ice in an ice scenario of heating, then you should know that the ice wasn't pure. Okay, it wasn't pure. And that is what leads us to discussion of finding out about pure substance. And for that matter, let's describe a pure substance. What is a pure substance? A pure substance is a substance, especially like you get that pure substances, they always have traits in that they always melt and boil at a specific temperature. There is a certain temperature that when it arrives, it will melt, okay, and the temperature will remain constant during that time. And there is a time that when it boils, the temperature will remain constant at a particular temperature, and it will all melt, okay, or when boil. So pure substances, they melt and boil at a particular temperature. And if that substance that you expected was pure, it fails to melt or boil at the temperature that you expected, then that substance is probably not pure. So a pure substance, it is a substance that contains only one substance, okay? A substance that contains only one substance. And it doesn't contain any additional impurity, okay? It is a substance that consists only of one substance without addition, okay? It is a substance that contains only one substance without additional of any contaminants. It consists of specifically only just one substance. And if you add anything to it, that substance that you added to that pure substance will make it impure. Okay? And that substance that makes it impure is referred to as an impurity. So an impurity is a substance that contaminates a pure substance. Okay? Yeah, and you should also know that for pure substances, they melt and boil at a definite temperature. So for pure substances, they melt and boil at a definite temperature. Okay? Yeah. So remember we said that when you add a substance to a pure substance, it will make it impure. Okay? Yeah. And that will lead us to a discussion also of the part impurities. What is an impurity? An impurity is a substance that contaminates a pure substance. Okay? An impurity. Whatever you add to a substance that was pure is considered an impurity. Okay? Yeah. So an impurity, an impure substance, but impure substances, there is a way that they also help, okay? Especially you will find in areas that experience snow, okay? In areas that do experience snow. In order to melt the ice, you will find them adding salt to the ice. Why? Because the salt acts as an impurity, and the salt will make the ice to melt at a temperature that is lesser than 0 degrees Celsius. So the ice will melt faster and much earlier before the 0 degrees Celsius falls. So that is why you will find that in the areas that do experience snow, they add ice to the, not ice, but they rather add salt to ice so that it lowers the melting point. So the effect of impurity is that they lower the melting point. Of substances. Okay, they lower the melting point of substances. And another effect they also do, they raise the boiling point. Yeah, so impurities, they lower the melting point, but they raise the boiling point. That is the effect of impurity. So for that will lead us to discussing about the heating curve and even the cooling curve of water, okay, of ice. So remember I said earlier that for ice, it melts at a temperature of 0 degrees Celsius, okay, and it boils at a temperature of 100 degrees Celsius. So we are going to plot this in a graph to see how a heating curve of pure ice does look like. Okay, so let's just draw. Yeah, if we have our graph that way, okay, if we have our graph that way, okay, then over here that is the y-axis, and over here we have the x-axis. Okay, and now on this side we'll be having the temperature, that is degrees Celsius. Over here we can just have time. Okay, as if each time also continues. So remember that we are going to heat. Okay, and over here, let's say that over here we are having at -5 degrees Celsius. See, yeah. Then here probably at 0 degrees Celsius. 0 degrees Celsius. Then we have it continues. Then over here we are having the 100 degrees Celsius. Then maybe here we are having the 110 degrees Celsius. Okay, and so on. So remember that whatever we are heating here will be ice that will turn to water, and so on. Okay. So remember, when you start heating, the temperature will do what? Temperature will rise. Okay. So temperature rises, and then it arrives at the 0 mark. Okay. It remains constant for some time. Then it kicks off again. It rises. When it reaches the 100 mark, it remains constant. It makes a straight line. Then once again it rises. Okay, it rises. So this one is the heating curve. Heating curve of pure ice. Okay. So remember at the downward part, before it arrives at the 0 degrees Celsius mark, okay, it was at a solid state. So over here we are having a solid state. Okay, when the temperature rises, the moment it arrives at 0 degrees Celsius, the temperature will remain constant until all the ice melts. And once all the ice has melted, the temperature will start doing what? Rising again. So the temperature was constant over here when it was changing from solid state to liquid state. Okay, so over here we're having the liquid state. So over there we're having the liquid state, which is now the water. Okay, now this one was ice at solid state, now we have the water. Then when it arrives at 100 degrees Celsius, the temperature once again remains constant. Okay, it remains constant as the liquid turns from liquid to what? Liquid to gas. Liquid to gas. Remember that we were heating. Now this is a heating curve. Okay, this is the heating curve of pure ice. Of pure ice. Okay, that is the heating curve of a pure ice. That is how it will look like. Okay, yeah. So in a scenario whereby, let's say, or even before we arrive to that, you check that the temperature is rising steadily, okay? And when the moment it arrives at 0 degrees Celsius, which is the melting point of ice, it does what? It remains constant, okay? Meaning that at this step over here, usually our melting does what? Take place at a steady temperature. So it is at a steady temperature. It has maintained a temperature, okay, at 0 degrees Celsius. Then it rises again. The moment it arrives at 100 degrees Celsius, the temperature once again remains steady. It is steady at a constant temperature, at a definite temperature, okay, until all the water has melted. It's when now the temperature as what? Rises again. Okay, now this is how the heating curve looks like, okay, of pure ice. Heating curve of pure ice. So let's say in a situation whereby the ice wasn't pure, in that there was an impurity that was added to the ice. For example, salt was added to the ice. How will it look like? Let's check on that. Let's check on that. We want to check on how will it look like if now it wasn't pure. Okay. So, if the ice wasn't pure, meaning that it was impure. Okay? If the ice wasn't pure, meaning that there was an impurity that was added to the ice, you want to check on how it will look like. Or, okay, let's say impure ice. Okay? So that is an pattern. Okay, now let's say at over here we are having the -5 degrees Celsius, the 0 degrees Celsius over here, -5, then here let's say it is at -10. Okay, so you are heating the impure ice. Okay, it was impure, you are heating. So the temperature rises, the temperature rises. So let's say the moment it gets to the -5 degrees Celsius, it goes this way. Okay, it goes that way. Then it rises again. It rises again. Then the moment it arrives at around 110 degrees Celsius, it goes this way. It goes that way. Then it goes that way again. Okay. So I want you to look at this graph, okay, and try to compare it to the graph that we had earlier. Okay. First, check over here. There is a slant. It is not steady. The temperature there, it is not steady. It has slanted. Okay. In that there is a range of temperature. Okay. The same applies at this point here. There is a range in the temperature, how it goes. Okay. Are you seeing that? So at this point here, it was still a solid state. Then here we have now the liquid of the ice, and now we have the gaseous state of the ice. Okay? So let's note, for impure substances, remember the impurity has messed up with the ice. Okay? In that, now it has melted at a temperature that is lesser than 0 degrees Celsius. But remember, for a pure ice, it melts at 0 degrees Celsius. But now this one has melted at a temperature that is less than 0 degrees Celsius. And the temperature, in fact, it wasn't steady. There was a range of temperature. Okay? In that, as it was melting, The graph did not make a steady move, okay? Instead, it slanted, okay? There was a slant. Have you seen that? So for impure substances, they melt at a range of temperatures. Okay? Yeah. Then once it all melted, now it was in the liquid state. The moment it arrived at the boiling point, you can also see that it boiled at a temperature that is above the 100 degrees Celsius, which is the boiling point of water. It boiled at a temperature that is above the 100 degrees Celsius. That is enough to tell you that impurities, they raise the boiling point of substances. Okay? It has raised the boiling point. And once it all boiled, now it is in the gaseous state. So it messed up with the definite melting and boiling point of pure ice. Okay? Have you seen that? You also realized it. So you get that? It raised the boiling point. So you get that the impurity that did what? Number one, it lowered the melting point. Okay? And you get that? It raised the boiling point of ice. Okay? It raised the boiling point. Okay? And you can also get that the temperature was not constant as it boiled or even melted. Okay? It boils and even melts at a range of temperatures. Okay? It melts and even boils at a range of temperatures. That is the effect of impurities on pure substances. Okay? Yeah, so if you are asked of the heating curve of a pure substance, you know what it looks like. Okay? When you are asked of the cooling curve, of the heating curve of impure substance, you know how it looks like. Okay? And the same also applies to the cooling curve. Okay? Yeah, so this is how it looks like. So I believe that you learned something very fast. You've learned of the heating curve in just a few minutes. Yeah? And the pure substance, the definition, I believe that now you have it at hand. Okay? So, maybe in our next class, we'll learn on the second learning area under matter. Okay? We are done with the first learning area under matter. So, see you in our next class. It will be ready. I hope to see you there. And please have fun during these learning sessions. Bye. See you next time.